Next example, students. Let P, Q and R be three distinct prime numbers. Check whether P, Q, R plus Q is a composite number or not. Further, give an example for three distinct primes P, Q, R such that first one PQR plus 1 is a composite number. Second one PQR plus 1 is a prime number. First, students, we solve the whether PQR plus Q, whether PQR plus Q is a composite number or not. Okay. So let us solve it. So I write here PQR plus 1. Okay. So now PQR plus Q. Sorry, PQR plus Q. So here we get the common from this number, that is the PR plus 1. So now here students, we know that the Q is a prime number. Okay, Q is a prime number, and here PR plus 1, that PR plus 1 should be greater than 1. PR plus 1 should be greater than 1 because the P is a prime. See here, P is a prime, okay, and R is also prime. R is also prime number, and the we add 1 in the product of the prime numbers, then it should be greater than 1, students. And that's why here the PQR plus Q have the factors and that factors are 1, then here Q, then here PR plus 1, and as well as the Q PR plus 1. So now here students, as the one number having these 4 factors, that means that number should be composite number. So here we say that therefore PQR plus Q is a composite number. Now students, we have to solve the first one. PQR plus 1 is a composite number. PQR plus 1 is a composite number. So now that it can be solved by giving an example. Okay, giving an example. So let us see that for the first example, that is we have to show out that it is a composite number. So let us take as P as 3, Q as 5 and PQR as a 7. Okay, P is equal to 3, Q is equal to 5 and R is equal to 7. So now here, if you substitute these values in this equation, that is PQR plus 1. Okay, so then here that 3 multiply 5 multiply 7 multiply 1. Okay, so that means 3 5s are 15, 15 7s are 105 plus 1. So that means 106. Okay, so the answer is 106. So that's why we can say that 106 have the many factors, that, or we say only more than 2 factors, 2 or 3 factors. So 106 is a composite number, and automatically that we say that the PQR plus 1 is a composite number. Okay. Then now secondly, that we have to prove that PQR plus 1 is a prime number. So now giving the examples, that as the P is equal to 2, Q is equal to 3 and R is equal to 5. Okay. Then substitute these values in PQR plus 1. Then here 2 multiply 3 multiply 5 plus 1. Okay students. Now here students, we assume such a number of PQR that should be a prime number, because our condition is as given condition is that PQR be 3 distinct number. Okay, so we have to take out such a number which are prime number and as well as they are distinct to each other. So now here the 2 3s are 6, 6 5s are 30 and 30 plus 1, that is equal to 31. So now here the 31. 31 is a prime number, students, and that means automatically we can say that therefore PQR plus 1 is a prime number. Okay, student. So such a way we can prove that PQR plus Q is a composite number, PQR plus 1 is a composite number, and PQR plus 1 is a prime number by giving the suitable examples. One example, students, prove that 4 root 2 plus 5 upon 3 is an irrational number given that root 2 is an irrational number. So now here, students, we have to prove that 4 root 2 plus 5 upon 3 is an irrational number. So let us we assume assume 4 root 2 plus 5 upon 3 is a rational number. Okay, it's a rational number. As 4 root 2 plus 5 upon 3 is a rational number, then it can be represented as a upon b form. So now here, students, we know that a and b belongs to integer whether b is not equal to 0. A, B belongs to integer and B is not equal to 0. So that means we get this form. Then here, students, 4 root 2 is equal to A upon B minus 5 upon 3. We simplify this equation. So here 4 root 2 is equal to 3A minus 5B upon 3B. Okay. Then here root 2 is equal to 1 upon 4 multiply 3A minus 5B upon 3B. So that means here 3A minus 5B upon 12B. Okay, and this is the value of root 2. This is the value of root 2. So now here, students, if you observe the right hand side, that is 3A minus 5B upon 12B. So it is, of course, it is a rational number. It belongs to the rational number. Okay, it belongs to the rational number. But students, the root 2 does not belong to the rational number because that root 2 belongs to the irrational number. Root 2 is an irrational number. So that root 2 belongs to rational number and that is a contradiction. We get the contradiction. Okay. So now here, as we get the contradiction, that means that assumption is wrong. Our assumption is wrong. Okay, that means our assumption is wrong. So here our assumption is wrong. That means we can say 4 root 2 plus 5.3 is an irrational number. Is an irrational number.